In this example, we're going to solve this radical equation. And the first thing you'll probably notice is that we have all these terms on the left side equal to 0, and there are, in fact, multiple radical expressions here. So, in order to facilitate solving this, we would like to isolate one of these two radical expressions and then square both sides. So what we're going to do is add this square root of 8m plus 1 to both sides. And that way we'll have this guy isolated on the right. So what we have right now, it looks like, is the square root of 2n minus 1 plus 2 equals the square root of 8n plus 1. And the reason we chose to transition this term over to the right side is because he was negative on this left side, so we know he'll be positive over here on the right side. All right, so now it's time to do the inverse operation of the square root, which is squaring both sides of this equation. On this right side, it's really nice because the square and the square root will cancel one another out, and we'll be left with just 8n plus 1, no more square root. But on this left side here, and quite frankly, this is the point where most students, if they're going to make a mistake in this type of problem, it's going to be right here. So we have this binomial expression. We have the radical here and then plus 2, and we're squaring it. So we could use the binomial formula, or you could put them side by side and multiply them out that way if you would like. Okay, so we're going to square the first term. So basically squaring a square root just gets rid of it. So 2n minus 1. And then we're going to multiply the two terms together and double it. So it'll be plus 4 times the square root of 2n minus 1. And then square the second term. So that'll be plus 4 there. We'll move up a little bit to make some room. And now we need to go ahead and isolate this other square root expression so we can square both sides again. All right, so we have this 2n, so let's minus 2n from both sides, and the negative 1 plus 4, that'll make 3, so let's subtract 3 from both sides. So what this will do, it'll cancel those, the negative 1 and positive 4 and minus 3 all cancel out. So we have this 4 times the square root of 2n minus 1 equals, it looks like 6n minus 2. Okay, well, we could divide everything by 4 here, but that would cause some fractions over here. But I do notice that all of these values are even, so let's make these values a little smaller by dividing everything by 2. And so when we do that, it looks like we'll have 2 outside that radical, so 2n minus 1, and then we'll just divide out all these by 2. So 3n minus 1. Okay, so here we are. We have a single radical expression left, so let's go ahead and square both sides one more time in an effort to get rid of this last radical. So we'll square the 2 out front, and we'll also square this square root. So 2 squared is 4, and we'll multiply that by the 2n minus 1, which is now no longer in the radical. And then we're going to square this right side. So it looks like we have this binomial that we're going to square. So 9n squared, and then we'll multiply the two terms and double it. So minus 6n, and the square of the last one is plus 1. So let's distribute. So 8n minus 4 equals 9n squared minus the 6n plus the 1. That right side just comes on down. And our n squared is positive on the right side. So let's go ahead and move all these terms over. So we'll subtract 8n and add 4. Subtract 8n and add 4. So all of that cancels, and we have 0 equals, and it looks like a nice quadratic equation here. So 0 equals, and it looks like this will factor nicely as well. It looks like 9n minus 5 and then n minus 1. So we can use our 0 property of multiplication because we have a couple of factors, and we know when we're multiplying them we get 0. So that means, one of those has to be 0. So we'll accommodate for both of them. So we'll say 9n minus 5 equals 0 and n minus 1 equals 0. And when we solve each of these equations independently, in we have 5/9, and we have, it looks like, +1. Well, okay. So remember, with these problems, it's possible to get extraneous solutions, which means that just because we got these two values of n doesn't mean they're both going to work. So what we're going to go ahead and do, I'm going to rewrite this equation, and we need to plug both of these values into the original equation and, see if they work. Okay, so I've got it written down. And let's try the 5/9 first. Okay, so 2 times 5/9, that's going to be 10/9 minus 1, which will be 9/9. That's in that square root. And then 8 times 5/9 will be 40/9. And then we can get common denominators, 9/9. And then plus 2 equals 0. Okay, so 10 minus 9 is 1/9. So that's the square root of that, which will be 1/3. Then we have 49/9. Okay, well that's nice because both of those are perfect squares. That'll be minus 7/3 and then plus 2. Okay, well 1 minus 7 is -6. So -6 over 3 is in fact -2. So -2 plus 2, yeah, that makes 0. So that works. So we know this 5/9 right here works, so we're very happy with that. So let's go ahead and try this n equals 1 as well. So I will one more time copy down this original equation, and we will plug 1 in for our value of n. So 2 times 1 is 2, 2 minus 1 is 1, and the square root of 1. So 8 times 1 is 8, plus 1 is 9, so square root of 9, and then plus 2 equals 0. 1 minus 3 plus 2 equals 0. Yeah, this looks pretty good. 0 equals 0. So that one also works. So it appears like both of these values that we got worked out. Neither one of them happen to be extraneous solutions. So we can say n equals 5/9 and 1. And here's that equation, the original one here. We went through the process of squaring the equation twice, once for each of these radical expressions. And then we had this nice polynomial. We factored and solved, and we ensured that both values worked, and indeed they did. So there's that solution.